before I move out of this section, I'm just, my eyes went to number 54. It says, sketch the graph of a function f of x satisfying all the given conditions. All right, so they told you on number 54, f prime of x is greater than 0 and f double prime of x is less than 0 for all x. Okay, so that means this function, what two things can you tell me that this function f is doing? Good, it's always increasing, right? Because f prime of x is always greater than 0. So it's always increasing. And what else is it doing? It's also always concave down because of that f prime of x, f double prime of x. So this seems like an example, and you just have to draw a function that does that. To me, the best example would be like the logarithm function, right? The logarithm function is always increasing and always concave down. That's a picture of, that's a possible f. The square root, a square root function would work also. Except it's for all, well, it does say for all x. I'm going to find me in trouble there because that's only true for x is greater than 0. Well, I don't know. That's an example. Okay, do we have another? So 55 and 56, you might look at those. Should I look at 56 in that section, or are you ready to move on?
I thought that if f, like f double prime is negative, I thought f prime is decreasing. Or it can.
Well, that is true,
Right.
but that doesn't tell you what we want to graph f.
Right. So I just thought that every time that it's negative, it has to be like decreasing.
Every time that see, what I want you to be very careful with is it's. Every time it's, then it. Who are you talking about? You are right that when the second derivative is negative, the first derivative will be decreasing, but the original function will be concave down. So we were only asked to graph the second derivative. So yeah, I mean, we were only asked to graph the original function. So yeah, there's some other stuff in here, like you could sketch the derivative if you wanted, but that wasn't what they asked for. Yeah. I'm going to do 56.